Welcome to all of cadets. How are you? It's a very critical moment to you all. You know, the COVID-19 has dispersed everywhere in our country, and you know many people is being affected every day. So be safe and sound and stay your home and don't go anywhere from your home. I am Muhammad Ashikur Rahman, lecturer in chemistry at Borishal Cadet College. Today I am going to start my last lesson in this chapter, which is periodic table, and the topics which we'll taught today is the position of elements in periodic table and the periodic properties and related terms. By the end of this lesson, cadets will be able to determine the position of an element in periodic table, explain various periodic properties of elements such as atomic radius, ionization energy, which is symbolized by IE, electron affinity, which is symbolized by the symbol EA, etc. And finally, you will be able to explain various terms related to periodic table like alkali metal, halogens, etc. Now move on to the position of an element in periodic table. The position of an element in periodic table can be determined from the electronic configuration of that element. Consider the first example, which is sodium. The electronic configuration of sodium is shown here. Here we see that the last electron goes to the 3s orbital. So here the group number will be 1 and the period will be 3 here. And the next example is chlorine. The electronic configuration of chlorine is shown here. From here we will see that the number of electrons in its last energy shell is 7 because 3s orbital contains 2 electrons and 3p orbitals contains of 5 electrons, so the total number of electrons is 7, and for a non-metal 10 will be added to these electrons, which is ultimately will be 17. So the group number is 17 and the period is 3 because the maximum energy shell of chlorine is 3. Now move on to the next example, which is iron. The electronic configuration of iron is shown here also, and we see that the total number of electrons of 3d and 4s orbital is 8, so the group number will be 8, and as the last or maximum energy level for iron is 4, so the period number will be 4. And the last example, which is copper, and the electronic configuration is shown here. And here we see that the total number of electrons of 3d and 4s orbital is 11. So the group number is 11, and as the maximum number of energy shell of copper is 4, so the period number will be 4 here. Move on to the periodic properties of elements. First of all, consider the size of the atom across the group. In a group from up to down, with the increase of atomic number, new energy level or orbit is added for accommodation of electrons. As a result, atomic radius or atomic size, every atom increases. Now consider the size of the atom across the row or period. In a period, with the increase of atomic number in each atom of every different elements, one electron is added one by one without change of energy level. As a result, effective nuclear charge increases and outermost valence electrons are attracted more by the nucleus. So, atomic size decreases in a period from left to right. Now, move on to the next periodic properties, which is ionization energy. The amount of energy necessary to remove 1 mole of electrons from outermost orbit from a mole of gaseous atoms of an element in its ground state to form a mole of unipositive ions is called ionization energy of that element. When we move from top to bottom in any group, then we see that the number of energy shell increases in every case, but the number of electrons in its outermost energy shell remains same. As a result, the distance between the nucleus and the outermost energy level containing electrons increases more and more when we move from top to bottom, and the attraction between the nucleus and the electrons in its outermost energy level decreases. That's why the lesser amount of energy is needed to remove the electron from the outermost energy level. That's why the ionization energy decreases when we move from top to bottom in any group in a periodic table. And if we move from left to right in any period of periodic table, then we see that the energy level of the electrons remains same, only sub energy levels increases. As a result, the distance of outermost electrons does not increase but reduce a little. Besides this, the attraction of nucleus increases on outermost electrons. That's why more energy is necessary to remove electron. It is clear that in any period the element of group 1 has lowest ionization energy and inert gas has highest ionization energy, which is shown in every period of periodic table, like the second period, third period, etc. Now move on to the next periodic properties, which is electron affinity, the amount of energy released when 1 mole of electrons is added to 1 mole of neutral gaseous atoms of an element to produce 1 mole uni-negative gaseous ions is called the electron affinity of that element. Now consider the group of periodic table. If we move from top to bottom in any group, then we see the outermost electron remains same in every element from top to bottom, but the distance between the nucleus and the outermost energy level containing electrons increases more and more. So the attraction between the nucleus and the outermost energy level containing electrons decreases more and more. So the incoming electrons cannot easily enter into the outermost energy level. That's why the electron affinity decreases from when we move from top to bottom in any group of periodic table, and then when we move from left to right in any period of periodic table, then we see the number of principal energy level, that is the outermost energy level remains same, but the outermost electrons increases one by one when we move from left to right. So, and in the same way, the nuclear charge also increases one by one when we move from left to right. As a result, the attraction between the nucleus and the outermost energy level containing electrons increases more and more. So the atomic size decreases more and more when we move from left to right. So the incoming electrons easily enter into the outermost energy level. That's why the electron affinity increases more and more when we move from left to right in any period of periodic table. This is a simple chart where all the periodic properties are included here. First one, the electron shell. The number of electron shells remain the same when we move from left to right, and electron shells increases by 1 when we move from top to bottom, and for valence electrons increases by 1 when we move from left to right and remains the same when we move from top to bottom, and for electronegativity increases when we move from left to right and decreases from top to bottom, and for ionization energy increases from left to right and decreases from top to bottom, and electron affinity increases from left to right and decreases from top to bottom, and the metallic character decreases from left to right in any period of periodic table, and non-metallic character decreases from top to bottom, and the non-metallic character increases from left to right, and the metallic character increases from top to bottom in any group of periodic table. Here, this is another chart from where you can learn all the periodic properties concisely. Now we will move to the final terms of periodic table, which includes alkali metals, alkaline earth metals, transition metals, chalcogens, halogens, and noble gases. The elements of group 1, which includes lithium to francium, is called alkali metals because this type of metals can produce most of the alkali compounds. And the element of group 2 is known as alkaline earth metals, which includes from beryllium to radium elements, and the elements from group 3 to group 12 is known as d block elements, and from here the elements from group 3 to group 11 is known as transition metals. This type of elements can form colored compounds and show variable valency. Here, especially the elements of group 11, which includes copper, gold, etc., is known as coinage metal because most of the coins can be produced by these metals. Now chalcogens, the elements of group 16 is known as chalcogens, and the group of elements is 17 is known as halogens. Halogens means salt maker. The last group, which is 18 groups, known as noble gases, which includes helium, neon, argon, krypton, xenon, and radon. This type of elements are known as noble gases, as this type of elements cannot form compounds by donating, sharing, or accepting electrons, and that's why this type of elements cannot participate in any chemical reactions. So this elements is known as noble gases. Now some of the findings of this lesson. From this lesson, position of an element in periodic table can be determined from the electronic configuration. An element possesses only one position in periodic table, which is known from this lesson. And finally, we learn here periodic properties changes periodically. Now the home task for you. First of all, the home task on position of elements, and you have to analyze that an element possesses only one position in periodic table. Now home task on periodic properties. First of all, you have to explain the periodic properties of the following group, like group 1, 2 and 17 in according to atomic size and radius and ionization energy. And secondly, explain the periodic properties of the following period, like period 2 and 3 in according to atomic size and radius and ionization energy. And finally, a creative question is shown here. From here, you have to solve some of the question which is included here. Okay boys, now I would like to conclude here. Be safe and sound and stay your home, and don't go anywhere from your home during the COVID-19. Okay boys, thank you and thank you all.